Great. Thanks, everybody, for joining. Welcome to another edition of Cassandra Lunch. We have dropped the COVID edition banner because we're probably going to continue doing this, indefinitely. I think it's a great thing to have people talking about Cassandra and recording conversations around Cassandra. Today, we're going to focus on deployment and admin tools. I have a general outline.
Just curious, can you hear me? Because I can't hear you.
Yeah, we can hear you.
You can hear me?
Huh. Yep. I think the speaker may be on mute.
I cannot hear you at all.
Your speaker may be on mute. Aku, can you chat David and tell him that his speaker may be on mute? All right, great, thanks. So yeah, today we're going to be covering deployment admin tools. I have a general outline of what we have used in the past and, the technologies that are available today, what were available before, and some of the new ones that are coming up. Always looking for people to help co-organize. We're part of a larger community called Data Community DC and looking for folks from different backgrounds to come present. Data Community DC is a family of meetups around data. We cover all things related to Cassandra, so anything that runs CQL, which is beyond Cassandra at this point. Normally at this time, somebody who's new to the group would introduce themselves, but everybody here looks like has been here before. Group rules, ask a question if you have it. You can also ask it in chat and whatever you're comfortable with. You can also use that as an opportunity to share something new, add something to the conversation. We'll welcome that interactivity. DataStax is a sponsor for this meetup and also sponsor with our company Anant. GW is a great sponsor for Data Community DC in general. We have some local sponsors in the DC Chicago area. Data Community DC is supported institutionally by several organizations in the DC area. All right. Any announcements? Anything coming up? Akwi, do we have any announcements?
None at this time, no.
All right. So actually, normally we put this out there, but now more than ever, we are bombarded with requests to help clients and don't have enough qualified team members with the hours in the day. So, if you're interested in learning this stack and working as a freelancer or as an employee, we have opportunities. Cassandra Lunch is now available on YouTube. You can watch all the videos we've recorded so far. Just go to YouTube and look for Cassandra Lunch. Cassandra.Link is our publication, which has content gathered from around the internet, curated by our experts on our team, as well as some blogs that other people write. Let's see. We had an event yesterday, building a real-time event-driven API with Kafka and Cassandra. This was broadcasted through the DataStax speakerphone, which is, now they do workshops 4 days a week. So Tuesdays are usually for the expert topic, and so we're fortunate in talking about Kafka and Cassandra and different ways to connect. That video will be up somewhere, and we'll have a blog post related to that. We always do this every Wednesday, and always welcome to talk about something, even if you're a newbie. I don't look at that as a bad word. Even if you're new to this stuff, you want to talk about something, you want to showcase something you're working on, here's a good forum for you to do it and put your content out on the internet. Okay. So today, as I mentioned, we're going to talk about admin tools, and we've covered a variety of topics in Cassandra. One of the biggest questions I get is, what are the ways to install Cassandra? Well, if you're installing it on one computer, you just do an RPM. So we'll just say, local, right? You can basically install using RPM, Debian, or using the tar.gz. And, I'll come back to this and say, why would you do one over the other? In a distributed environment, and basically when we're talking about distributed anything, it's a big, either machines, virtual machines. Generally after the machines are deployed, people usually use Ansible. We'll talk a little bit about that. We'll take a look at some of the code that's available out there today. Some people use Puppet and Chef. Personally not a big fan. Never really cared for it. And Ansible seems to be, generally, if you talk to anybody who does Cassandra or DataStax or any type of distributed environment management, Ansible is generally the top for managing a system once it's running. We'll see why that's like Ansible is conducive to managing a database. Infrastructure, generally, people use things like CloudFormation or Azure Resource Manager templates, but Terraform is kind of a common language that can work with different clouds. I mentioned this because when you're dealing with a distributed environment, you're eventually going to have to add new machines. You're going to have to add new systems, and how quickly you can do that is dependent on your automation. So while the infrastructure technologies help you create new machines, the configuration software allows you to configure them after the machines are up and running. There are some tools that are available commercially to help with this stuff. And actually, Offcenter Lifecycle Manager is one of the ones that you can use to, here, I'll call this installation. Offcenter has some qualities of Ansible. And then lately, from an installation configuration perspective, people have been using Docker files. So even without using Kubernetes, it's possible to use Docker, like one container of Cassandra on one machine. The Docker file has all of the customizations. That's another way to do it. Actually, I'm going to get this in a different category. I'll just say this is related to containers. And then Kubernetes is what allows us to do even more advanced orchestration. But I look at Docker and Kubernetes as related, but you can use Docker without using Kubernetes to do Cassandra. In fact, there's a good YouTube video by the InstaCluster folks way back when, where they had to support so many different, even before they were using Kubernetes, they had to support so many different versions of Cassandra and so many different operating systems and so many different clouds. So they just standardized on Docker. So they would just run Cassandra on Docker on a virtual machine, and it made everything easier. And then in terms of like administration tools, there are several open source and some commercial tools as well. And these are just some of them. There's Offcenter is one that's commercial, but there's something called Cassandra Reaper, and we talked about Repair before. There's Grafana, commonly used with Prometheus. But in terms of actually dealing with day-to-day, there's some power tools that if you're doing Cassandra, you should get to know. Because when you're dealing with Cassandra, you're dealing with many, many servers, and you may have to do an operation on many servers at the same time. And you may not have any of these goodies to help you do that. So ultimately, you're going to be stuck with SSH. And so there are some tools that make SSH management a little bit easier. So let's kind of walk through this. I actually have a deck that I can repurpose for some of this, and I'll come back to this. So I'm just going to bring that up. Let me know if you guys can see. There's a video for this presentation somewhere on our Anant YouTube channel, but I'm not going to go through this whole thing. In fact, this is a hands-on live workshop we did as well. But this layout that I'm going to show you is, I think, the best of all technologies for installing and configuring a cluster of like a small to medium size. And you'll see why I say it's not really for large ones in a second. Everybody knows that we should be doing things automated. And if you don't know that, that's okay. You'll eventually learn that when you're dealing with a distributed system, you basically have to use automation technologies. Although there are some clients we work with that don't, unfortunately. But you know what? They pay for our time. So there you go. So in this example, we wanted to do a setup of data stacks, and essentially there was one node for Offcenter, and Offcenter has its own Cassandra to store its data. But we wanted to have a data center. I have two data centers in one cluster. So one data center with one node here, and one data center with one node here. And later, we wanted to expand it so that DC1 would have 3 nodes and DC2 would have 3 nodes. And that's a common scenario. You start off small and you add, right? And so looking at all the things that go into, managing a cluster and across different types of operations, here's a grid. If you can see this, it may be too small. I'm going to walk through each of them. All right. So there's 4 columns: system operations, data stacks itself, data stacks agent, and service operations. Now, if you're not using data stacks, that's okay. You won't necessarily have the data stacks agent, but you would have Cassandra here, right? And on the left side, the different rows are areas of automation or operations. So infrastructure, getting the infrastructure ready for all of these things, installation of the system, configuration of the system, maintenance and upgrade. And so while the infrastructure setup and installation is generally one time, configurations should be done several times over the course of a lifetime of a cluster. General maintenance obviously would be done on a weekly basis, maybe daily basis, or ad hoc. And then upgrades happen probably once a year or every other year, right? And in this setup, the recommendation I had was use Terraform to set up the infrastructure, use Ansible to deal with the basic system operations of getting, the user set up or setting up specific, there are some settings on the operating system that we do whenever we create a new cluster, to use Ansible for any system operating system, operations. And then the rest of it would be done via Offcenter Lifecycle Manager. Now, if you don't have Offcenter Lifecycle Manager, you can replace every part of this where it says Offcenter with Ansible, okay? And there are a lot of open source Ansible playbooks out there, and we'll take a look at a few of them, and then you can see how to do this. So it's not rocket science, and you don't have to deal with a DataStax agent. But if you were using Grafana, you probably have a Prometheus exporter. So something like the DataStax agent, you'll have to install it or manage it, right? So it's worth looking at what Offcenter does. You know, you can download and use DataStax for free and check out what it does, even if you don't intend to use it, to get an idea of like what this tooling does for you. And some of the automations you may not need. So in Offcenter, you can change literally every configuration file as a template of the cluster level, the data center level, at the node level, right? And it merges all those things for you and pushes it out. Well, you can approximate that with Ansible. But if you know that you're never going to be changing, you know, the Cassandra ENVSH, you may not have to really work on a playbook that pushes out Cassandra ENVSH. You may just have to worry about Cassandra YAML. So this is the best case scenario of using the right technologies for the right task. But Offcenter LCM, in my experience, works great. It used to be a piece of crap, by the way. It used to be a total piece of crap. It didn't work at all. In the later versions of it, it has done well. You know, we've used it with customers that have like 20, 30 nodes in a cluster, several data centers, and it works fine. I think the biggest one I tried was like a 30 node cluster with 3 data centers, you know, 10 nodes each, and it was working perfectly fine. There's some tweaking that you have to do to make sure that it runs, you know, and executes. But those gotchas, you get to learn that everything has a gotcha. Ansible has a gotchas, Terraform has gotchas, Offcenter LCM has gotchas. But for somebody who's starting off, doesn't know anything about Cassandra, Offcenter has the right patterns to mimic with whatever tooling that you use going forward. So why not just use everything, one tool for everything? Well, you know, generally speaking, Ansible is not the best at dealing with infrastructure. It can, but it's not the best. Likewise, Terraform is great at infrastructure, but it's not really great at configuration management. It can be used for configuration management. I don't think it's really the best tool for it. As I mentioned, Offcenter can do DataStax specific things really well, but it's not for everything. It's not going to do everything for operating system level type stuff. It's not going to do patching for you for the operating system. It's just focusing on DataStax. And, you know, you don't need Offcenter. You can do everything that Offcenter does in Ansible. But in our, you know, case, we just wanted to use something that was already built. We didn't want to reinvent the wheel. Otherwise, also in AWS, you know, AWS has its own automations, and technically we could use Terraform to do everything. We could use it to create the VPC, the security group, and we do nowadays. But a lot of times you're walking into a scenario where these things are already created and you have to make this thing work. So realistic scenario is you're going to have to be installing a new cluster into an existing cloud, whether it's Amazon or Azure or Google. It doesn't really matter. But Terraform can help because it's one layer that abstracts dealing with the UIs. The syntax for Terraform is slightly different per provider, but it's fairly similar. I mean, you can navigate it. So once your hardware is created, Ansible can work on anything. It can work on cloud. It can work on, and by the way, after Terraform is done making the machines, Terraform is no longer running, right? It's done. It manipulates the cloud for you and it's done. Ansible is then really operating on AWS, or if you have Google, it operates on Google. Or if you have hardware, physical bare metal, it'll operate on bare metal. And if you're using Kubernetes or Docker, Ansible can actually operate on Docker containers, and it can even run Kubernetes. So Ansible is a general purpose Swiss Army, nice toolkit to do a bunch of things. But I think it really excels in the automation of processes across several things, several machines, several containers, several dog back there, several systems. Ansible is great for that. just advertising about ourselves. So, what does, Terraform look like? So Terraform code essentially looks like JSON, right? It looks very similar to JSON. And then when you apply it, it can output like what has happened. So when you say, I want 2 machines, whatever, it'll make these machines for you. It'll give you IP addresses. And then you change it and say, I want 6 nodes. It'll go ahead and make 6 computers, and it'll tell you what the old nodes were as well as what the new nodes were. Some people actually use the output of Terraform as the input for Ansible. So then you don't have to really do any, mapping. So Terraform's great. TK is not on today, but he's done a video on how to use Terraform with, AWS, with Kubernetes, like just the basics of Terraform. He gets into it. So, take a look at on our YouTube. But I look at Terraform as it's like magic. It's like, I would say it's like Docker for the cloud. In Docker, you know when you make a container, it's going to work on every machine. With Terraform, once you write that definition of what you want in one cloud and you hit apply, it will create exactly what you need predictably on that cloud. And then when you're done, you can say Terraform destroy, and it'll destroy all of the things for you. Not that you do that, but it's very predictable. It's just like Docker. Like once you have a Terraform manifest of everything that you need, it's going to be predictable on every account. So I love Terraform. They don't pay me to say that, but I really do love it. Ansible is different from Terraform. While Terraform just creates computers for you, this is agnostic of any software or operating system. So you can say, I want Ubuntu machines, or I want Red Hat machines on AWS, or I want Red Hat machines on Google. It doesn't really matter, right? It just makes computers for you. Now, if you have an AMI, like a golden AMI, with the binaries already installed, which some people do, then basically it shortcuts the process of installing the binaries for you for DataStax or Cassandra. Once the machines are up and running, Ansible is useful. What does Ansible do? Ansible makes changes. It makes modifications to systems, whereas Terraform makes modifications to a state. So you have a state that's locally stored and you manipulate it, it applies that state to the cluster. If you say remove one computer on your local manifest, it'll go remove that node from the cloud when you apply it. Ansible doesn't work like that. In Ansible, every time you run it, it makes a change on the remote system. So it's not maintaining like a super state like Terraform. It does maintain a local state on each computer to check if a particular playbook or a role or a task has been run on that machine. Ansible, the way it works is that you have an inventory of computers, and in that inventory of computers, you can have variables associated with a group of hosts, or you can have variables associated with the whole, with every host, and you can then apply tasks to that inventory, or you can have a role. A role is a collection of tasks, or you can have a collection of roles, which is called a playbook. And or you can have a role of playbook of tasks. But at the end of the day, you can say, I have 20 computers made by Terraform. Go and apply the role of security patches. And it'll go and apply that to every machine. And if one machine was not responding and you run it again, it'll say, oh, 19 out of the 20 machines this has been applied to, so I'm going to run it again on this 20th one. Okay? I want to install Cassandra. So I have a playbook to download the tar GZ and unzip it and put it into a particular directory. Do that on all the machines. Done. I want to push out a configuration. So that's where if you have files on your, generally we have an Ansible bastion. You don't need to install Ansible agents on these different machines, because Ansible running from one computer essentially uses SSH to then go execute things for you. That's how it works. Same thing with Terraform. You don't need to have agents installed on your clouds. Terraform runs on one computer. So generally you'll have one computer with Terraform and Ansible, and that's your cloud bastion, and you can orchestrate, you can create machines, you can apply these Ansible playbooks from that one machine, and do everything basically with that one machine. If you're using Offcenter, generally, you would have one of your Offcenter nodes as your Ansible bastion to do all of that stuff. Ansible is a great tool. We have some videos on this. I like Ansible because if you can't do something with the Ansible tasks that are already there, you can go gank it from Ansible Galaxy, which is an open source library of other people's playbooks, or you can make your own. You can make your own tasks, specialized things using shell scripts that it can apply universally, or you can do it with Python, like a real Ansible module. One of our team members, Ion, who's really helped with some of our internal automations, has made modules in Ansible. So, you know, even with DataStax, Offcenter, LCM, Ansible is still useful because there's some operating, system tasks that you don't do with DataStax. It's just not part of that toolkit, and it's useful to take a look at both. If you're not using DataStax, it's okay. Ansible will take care of pretty much everything for you. All right, so that's kind of like the overview. And before I go back to the rest of the topics, any questions about Ansible or Terraform or Offcenter LCM? No? Okay. I do have a screenshot of Offcenter LCM. So this is different from the Offcenter monitoring. You kind of create a cluster, you add data centers, you add different nodes to it, and each node has some settings, each data center has some settings, each cluster has some settings, and they basically merge these when they push these out. And if you have ever used Ansible, very similarly, it'll say success, this was done, this was done, this was done, or failure. And you can then rerun that job essentially to apply that change. All right. So we talked a bit about Ansible, Offcenter LCM. Puppet and Chef do similar things to Ansible. You guys can Google Puppet and Cassandra and find stuff on there. I'll take a look at some of the Ansible scripts in a second. Terraform we talked about. Again, if you use Terraform, you kind of supersede these things, and you're better off because you can use that on any cloud eventually. Docker and Kubernetes. So Docker is an all-purpose kind of DevOps tool. People use it for many, many different things, including like compiling something, testing it, destroying the cluster. But deployment with Docker, the way it looks like is that you still need a machine, right? So somebody has to give you infrastructure, whether you use Terraform to make it or you have a physical machine. And if you install Docker on, let's say, on a host, on that one node, you can install Docker to say, run a one node Cassandra instance here. And if you open up the ports between the hosts and you make sure your Docker containers ports are open, every time that you would have run Cassandra using RPM or Debian, you're basically running a Docker run command, right? So Docker is not, there's no intermediary between the operating system and Cassandra. Docker is just a way to like run the container. Cassandra is literally running on that machine via JVM. So the performance, nothing happens to performance if you're using Docker to run Cassandra or if you're just using Java to run Cassandra. There's not really that big of a difference. Why do that? Well, if you have a Docker file, which has all of the configuration items that you needed for that Cassandra instance, you'll have probably a Cassandra YAML outside of the Docker file that you're editing. When you say Docker run with that Docker file, okay, and you build that image and you put it in your registry, that image is sacrosanct, meaning every computer that you say Docker run, let's say Anant/Cassandra, which would be our golden Docker image, it would run that build of Cassandra with our overrides in the configuration. And as long as our ports are exposed, 9142, 9042, 7, all the JMX ports, et cetera, et cetera, et cetera, just like any other Cassandra cluster, a Dockerized Cassandra cluster would come up. This is not the same as if you were using several nodes of Cassandra in one computer. That's a different ball game, and that's generally where we're using something like Docker Compose or Kubernetes. Okay. Actually, you know what? I'm going to find. There's a deck. Here we go. Now, I mean, nowadays Instacluster just does everything on Kubernetes. Here we go. I think I got it. Nah, this is too technical. It's going to get really boring really fast. But there's a video by Instacluster about how they basically, here it is, I got it. And, you know, this is on Cassandra.Link, so you can find it. So basically, their challenge was, you know, how do we run different applications? This is more of a sell of Docker, but for them, here, we know what Docker is. Keep going. Yeah, so they basically converged on, you know, using something like CoreOS in Docker, and everything came down to them deploying CoreOS across their clouds, but because it was the same Docker file, it was able to execute the same way across all their different clouds. And because it's a Docker file, it will run exactly the same in their local environment, in their production environment, in their staging environment. This deck really just talks about some changes that they had to make. Unfortunately, this is still not the talk that I was looking for, but it is well documented. Cassandra on Docker is well documented. Even though there's an official Cassandra Docker image, there is a official DataStax Docker image. Kubernetes, we have talked about before, we'll talk about again, is the way to containerize and orchestrate everything, not just the database. But this is too short of a session to just talk about, you know, Kubernetes. Any questions about containers as a way to deploy Cassandra? In terms of administration, right? Let's say you have everything up and running. You know, one of the best ways to kind of manage and administer Cassandra, I kind of break that into two ways. One is to monitor. There's something called Offcenter Monitoring. That's one. Another would be Prometheus and Grafana. And then another one would be Elastic, FileBeat, and Kibana, or Logstash if you want. These are open source-ish. I mean, at least they're free. Offcenter used to work with older versions of Cassandra. Like the older versions of Offcenter used to work with Cassandra and DataStax, the newer one doesn't. But you know, these are just some of the ways you can monitor. You can also do New Relic. You can do data. There are so many different Datadog, right? Datadog, or Splunk. So log analysis is one of the best ways to know what's happening inside a live cluster. But there's other metrics that are easier to visualize using Offcenter or Grafana. Although if you were to put that stuff in these tools, you could see it there as well. And technically, New Relic and Datadog they straddle both. These guys, they do both. If you're monitoring and you're seeing that there's issues going on, how do you make changes to the system? Ideally, you would be doing things using, Ansible or Offcenter LCM, but every now and then you have to kind of get in there. One part of Offcenter is to be able to do things like rolling restarts, et cetera. Offcenter also does repair. Reaper is another tool to do repair. Makes your job easier. It's called Cassandra Reaper. We talked about backup and restore before. I'm not going to get into it, but the lowest common denominator is SSH, right? But doing SSH on several different machines is quite a chore. So commonly people will use something called parallel SSH. There's also something called Cstar, which is a here, let me find it. It's basically a equivalent to parallel SSH, and it's worth looking into. It's also on Cassandra.Link if you want to take a look at it. It's a Python tool, and you basically say, hey, go to every machine, right, and restart Cassandra, and it does it one by one, for example, right, rolling restart, and it'll go one by one. Data center by data center, node by node, and it'll execute it for you. It's kind of like Ansible and parallel SSH are wrapped into one with the knowledge of your Cassandra cluster. So Cstar goes beyond parallel SSH because it's intelligent in terms of knowing that there's a structure to these hosts. They're not just a bunch of IPs. You don't necessarily even have to know your IP addresses except for one seed host. And it uses the seed host to basically understand the topology to execute. Pro tool, highly recommend you use it. I'll put this in the resources so when we publish the blog post, you'll have it. The other is parallel SSH. And parallel SSH is, you can use it with any tool, right? It doesn't have to have Cassandra. So worth a look. You can use it in Python, or you can do it in Shell. It's really up to you. Copy this and put this in there as well. And you know what? There's one trick up my sleeve, which, not a lot of people pay attention to. And I'll just do a quick demonstration here, is basically a spreadsheet. And, I feel like I should just give this spreadsheet to people, but you can make it, right? So what I recommend to people is if you have a cluster, go ahead and we'll just say, temp cluster. And here, I'll add another host here, a row here, okay? So let's say this is DC1 and this is DC2, right? And these are my hosts, A, B, C, D, E, F, G, H, right? So whenever I do any change management, whether it's with Ansible or with Offcenter or with parallel SSH, okay, I always keep track of it in a system like this. Okay, it's a log. And here I'll put, like, let's say this is the date, right? And this is the change. And today is what, 10/7, all right? And I'll also add kind of the owner of this, who made the change, right? So let's say we have to do a rolling restart, right? And I have to do it. I can go ahead and I'm going to set up a conditional formatting. This is what makes it kind of a useful tool for communicating with everybody else, like what's happening on the cluster. And if it is, let's say, pending, like this. And if it is active, it is this. And if it is done, right? And what I'll say is that, you know, if I'm going to be changing the system and I need to communicate with everybody else that something is happening, then I'll say, hey, I'm doing a rolling restart. This is the change I'm making. And I'm going to go ahead and start it on one. And I'll go to the next one, and then this is done, right? So even if I have to manually do this, even if I don't have the ability to create a, or install something like Cstar or parallel SSH, and there are times where we don't have those tools because whoever created that cluster did not use any automation. They do everything manually. This type of organization of what you're doing helps not only you to organize everything, but to record everything, but also to show other stakeholders what's happening with the cluster. Because you're rarely working in a team without other team members, especially if you're using Cassandra, using it in a sizable operation, right? This is by far the best tool for Cassandra management, and it's not a technical tool. It's just a spreadsheet to show what's happening. Now, if you could also project what things need to be done. So let's say we need to be adding a cluster, adding a data center, right? So let's say DC3. And here, I'm gonna follow this down to up here. Sorry, I'm just kind of perfectionist when it comes down to these things, formatting. It helps a lot. Okay, so let's say we have to add a new cluster, add a new data center, right? So one of the first things we'd say is, okay, so tomorrow what we're going to do is we're going to create machines. Then we're going to do system patches. Then we're going to do system tuning. Then we're going to install DSC. Then we're going to push config. And then we're going to start DSC, right? And these are all things that I guess we can do tomorrow. And, you know, I'm the owner of this. And technically, nothing needs to happen on these machines, right? So what I'll have is I'll have a plan of action that, you know, yeah, there we go. So I have a plan of action. And as I go through this, even if I'm doing it manually, I have a sense of order to this chaos. After we add a new data center, we need to do repair. So we're going to say repair, right? And we'll start this on the following day, right? And this would be pending. Because we have to do repair on every machine, we have to track it. So if you're using something like this, your job to manage the cluster is easier, and you have a story of what has happened to your cluster. So many times, people do these system changes and they don't plan it out and they don't track it, and something goes wrong. And then you're like, okay, well, what did you do? So, well, we just did this procedure. Okay, so did you check to make sure that you did this procedure on every single computer? Oh, I don't know. Let's check, right? So, but if you had this log of you know, what has happened and when it happened, or what is pending, it's easier to debug what happened, right? Trust me on this. One of the biggest things we've done for clients is just introduce this simple planning mechanism to get things done on a distributed system. And, you know, what is this? This is just a manual version of Ansible. Because Ansible, when you say run this playbook on my host inventory, it literally goes and says, this is pending, this is now active, this is now done. And it keeps track of those things for you. Well, you can do that too. You can keep this as a running log of what's happening in your cluster. Okay. Any questions? And actually, you know what? I will make this public, so whoever wants to kind of use this template can use it. Can I do that here? Well, I'll figure it. We'll figure it out later before we publish it. Any questions about all the different topics that we talked about today? Oh, sorry, I didn't mention Mobx Term. So Mobx Term is a tool which you can SSH into many machines at the same time, and then you can do something called multi-exec, meaning it'll kind of like show a grid of all the machines. So as you're typing, the same type strokes are going, keystrokes are going to every machine. You gotta be careful with that, but it's actually pretty cool. Now I'm done.
Is there a,
well, if there are, go ahead.
I just want to just wondering what your suite of applications would be for everything from installation.
David, you're on the call twice. You have to mute the speaker on one so you can speak in the other one. Here, I'm gonna just unmute your phone and just press *6 on your phone, and then you can ask the question there. Okay. There we go. Go ahead.
Okay. Is this working any better?
Much better. Yeah.
Okay. It's funny because I was muted on the call, so I thought I was unmuting on the computer. Anyway, just wondering what your preferred suite of administration tools are. You know, you have so many here. What's kind of in your experience, your preferred suite? What works best with Cassandra? That kind of thing.
It's a great question. I get asked that all the time. So we actually have put it in this toolkit. Basically, I'll put this as part of the resources as well. So if you don't have data stacks, and even if you do, the same toolkit would apply. In my opinion, I think that Grafana and Prometheus will give you eventually a much better way of looking what's happening across your cluster than Offcenter does. Offcenter is okay. And then Elastic and Kibana, Offcenter doesn't have that. So unless you have Splunk, which is very expensive, or you're paying for some log analytic like Sumo Logic or Datadog or New Relic, Elastic and Kibana is free. That's no-brainer. You know, and then if you don't have Offcenter Repair, you use Cassandra Reaper. But this is pretty much it. Yeah.
Gotcha. Perfect.
Yeah. And by the way, you can download this code base, and there are some Ansible playbooks here, essentially to set up these tools on an existing cluster. Actually, I kind of like forgot to show you some of the Ansible existing Ansible playbooks, but this is an example of an Ansible playbook where we have a playbook to say restart the Cassandra service, right? And so what does this playbook have? This playbook basically says go to these machines, and you know, we have a variable for the Cassandra restart command because different environments will have different stop and restart command. And then it basically waits for that port 9042 to come up before it says I'm done. Okay, so this is a playbook that we can then apply to the whole host inventory. Here's another playbook to install different tools. And so this playbook, what we're doing is we're saying basically install this role. Install the Cassandra exporter role, install the tablesnap role, and this is, and I'll show you the roles in a second. we'll take a look at, I'm on GitHub. There you go. So let's say Cassandra exporter install is a set of tasks, and there's some templates. But okay, well, this one just includes this standalone. And you know, Ansible has certain modules already there. Like there's a file module to create a directory. This one basically downloads the tool. This one uses a template and applies some variables to that template and copies that file over to this file. Same thing here. And then this one installs that service into the systemd. So you can imagine if you have 100 computers and need to install the Prometheus exporter, you're going to have to do a lot of work on every machine. But if you use this playbook that we have here, you'll get the core tools. That's what this toolkit is for, so that you don't have to go and do it yourself. Okay? Other questions? Cool. All right. Yeah, this is to be extended. I mean, DevOps, deployment, administration is 1/3 of Cassandra work. 1/3 is development, engineering. Another is, you know, DevOps, deployment, and another is just general architecture. So something that we can definitely revisit again.
I'm not sure if
yeah. Go ahead.
I'm not sure if this would be the right form, I guess, for the question, but I'm just curious, like, with your customers, how much freedom would you say you have to choose the, you know, the applications you use for administration, or is it more often you're walking into a situation where they already have the tools and you kind of have to adapt to what they have?
Yeah, so I'll go one level down, okay, which is the lowest common denominator, okay, is basically you're going to have SSH access, and you're going to have Python, right, and you're going to have Bash. So if you cannot install any of these tools, eventually you're going to be stuck with using Python, Bash, and SSH. And it sucks, but if you have these patterns in your mind of how to do things, you can approximate a playbook in Bash or Python, and then you can reuse it again and again and again. That's nothing special to Cassandra. That's like in any environment where they don't let you install tools, you have to make do with what you have. But luckily, between Bash and Python, I mean, you don't even need Python. You can do everything with Bash, but Python has better libraries. That's unfortunate. In some scenarios, you don't have choice. So this is more of a political sometimes discussion in terms of you know, why we're not using Ansible or why we're not using Terraform. There's no technical reason for it. It's just a political reason why it's not being used. So
right.
Again, as I mentioned, right, they're paying us for our time. So great. I have actually been involved in a proposal where I recommended automation using Terraform, and the cost of the it was a cloud transformation, so moving from on-premise to cloud, and I recommended using, it was a new, you know, blue ocean, completely greenfield operation, right? The new thing, completely new. And I said, you should use Terraform because then the next cluster you create, it'll be that much easier. So you should invest some time into Terraform and Ansible. And they said, well, we're only going to be creating 2 clusters, and you know, we may create a 3rd one later, and we may create a 4th one later, but you know, we don't want to automate it. And I said, okay, fine. If you don't automate it, it's going to be the same amount of time to do it manually for these 2 clusters as if we spent some time automating it and then creating it through the automation. And they still didn't want to do the automation. So I was like, okay. Like, what can I do, right? I gave you the same exact budget. You don't want to do the automation, then I don't know what to do. So it has to be some sort of political reason. I don't understand why they didn't want to do it, but that's not under my control. All right. Any other questions? Well, we're at the top of the hour. The notes for this will be put up on the blog soon. Go ahead and if you haven't already, sign up for the Cassandra Lunch YouTube and just subscribe to it. You can find it on Google, on YouTube. And if you want, also sign up for the Cassandra.Link newsletter, which it's soon to be launching, to get weekly or daily updates to knowledge that we're putting on a daily basis. All right. Thanks, everybody. Have a wonderful rest of your week, and I'll see you guys same time, same place next week. Bye-bye.